Well, there ain't no other way when something is as important as this part right here is. When you're working on one of these McCormick-Deering Model M, either the kerosene or gasoline fueled models, spark plug or igniter. This is equally as important on all engines. It seems to be standard common response is that these old McCormick-Deering or IHCs, whichever way they're badged, are supposed to run with the choke, with this choke plate here partly closed or even closed. And that is just not the case. This engine was not built, designed to run with a partly closed or open choke as a normal running condition. Open that choke up. The problem is not the choke, and I will show you what the problem is. And this is not a one-time discovery. This is something that was gained over many years, not several, many years of working on this type engine. Even the 3 horsepower to 6, whatever you own, this is the problem. It's part of the problem, the 99% of the problem. If you have to run, and I am making a point, not a waste of time by no means, how important this is. This is the carburetor, the mixer carburetor, whatever you want to call it. That's the one piece. It had the two adjustments. This one had used the small rear cover, and it went with that indent, went to the inside. It did not go this way. And part of the reason that you have to run a partly closed choke plate is so often when you take these apart, put them back together, they don't put any sealer here. This is where you actually need to use a sealer. And do not use, categorically, do not use silicone sealer here. This would go on that one. The two sizes that you work with are, this is the bigger one, this is the smaller one. You can see how much difference they are. About 1/8 of an inch. Well, it's quarter all the way around. This one is the one that goes on the most common models. Just the one needle. Goes on the back. That's the two variations of those. When I took this engine apart and looked down in here, the problem is it has no spring in there. The spring is missing. And this is the spring right here. This is a very good example right here. And you can see these springs that I removed from mixers and just kept them as examples. In this you can observe how someone stretched this one out to 1.5 times its length, and that just put too much pressure on it. That was too much. There's 2 more examples of a pressure, and this one, and those are some kind of copper beryllium or something they're made out of, and you can wind your own spring to go in here. It's quite easy to do. But this is just a hardware store version here, which would have been much too weak, and this is a hardware version that I removed, and that would have been much too strong. This amount right here is still usable. These right here, you can see how weak and misshaped they are, and they would have been of no value in the engine. They would not have helped. And the way this thing works, when you put it in the mixer, when you put down in there, it seats out, and that's the problem. If I may get to it right now, the problem is the seat down in here is eroded, corroded, rusted, or some of them are just non-existent. The seat down in there. And if I might get one to show up on the camera, there's a seat down in yonder. And I did this in here a long time ago and just had it laying on the sideboard over there. But maybe you can observe a seat down in yonder with the light. But anyways, and I'm going to do that in the next part of this video. Show you how to reseat that. And if this is a bad, if the back of it right here is rusted away, then you need to face that off. The same goes if the bottom where the gasket goes, if it is rusted too much where you don't gain a seat, or one of the common, if you put a straight edge, a flat plate on the bottom of these carburetors, you will find so often that the front part right here has a bow in it, right in here. So if you want to set that right, then you just take put it in the milling machine and just take a light skim coat off the top of that, as I did here. This one was just rusted away so bad, and I just took just a cleanup pass. And you do need to note how much you removed off the top of this, because you do need to remove the same amount from the interior sleeve, or it'll be too long. And then face this off back here with the facing. When you face off that seat in there, when you reseat that, you make a note of how much material you remove from that seat, and then while you still got it in the mill, face off this back part right here the same amount, and then you can use a stock original equipment spring. If you remove on that seat down there 30, 40, 50 thousandths, then your spring will be too weak if you don't take 30 or 40, 50 thousandths off of here. Something else that comes to mind, a show and tell. One of the other reasons that you have to run a closed choke is valve stems that don't fit correctly, and you're just sucking too much air around them, or a little air around the valve stem and a little air around this backing plate here. This leaks. Then you have to choke it in order to compensate for all that air leakage. With that said, if you have a kerosene engine, and the way you know it's a kerosene engine is it will have this type of compensating valve. The spring would be on the back of this, in that area there. These two examples here are kerosene compensating valves. See all the holes in there? These are the aluminum type, and this is the metal type. You will encounter both types in the kerosene engines. If you want your engine to run better on gasoline, remove this and install the gasoline type. And as you can see readily, immediately, the difference is this one only has 2 holes and this one has 6. More air. And I did find an example in a gasoline engine of one of these factory made. This is a factory compensating valve that does not have any holes in it. It's solid all the way around. I would think this engine would run quite well. And as a rule, one of the reasons that I don't do restorations, and if I do a restoration, then I would build this part exactly to the dimension that this one is. But when I'm just building an engine to run a rebuilt engine, and I'm building these, And these are quite easy to build. I mean, you can just knock these things right out, either on the Grizzly lathe. This is a real good little project for the Shoreline lathe. But when I'm building these here in the shop, I only put a half-size hole in there. You can do the homework on that. This is one of the first things that you do need to change out if you're only going to be running gasoline. Your engine will love you for it. Okay, let's just see if we can get that seat down in yonder. Oh yeah, y'all see that seat that's been cut a long time ago. This one was just kind of. That is a necessary repair. And let's just get one at random. Down in, okay, if you can see down in there, see that seat is just non-existent. You can tell there was one there at one point in time. Just all of these right here are good candidates for a reseating, and we'll do that. We're going to get over there on the milling machine, and this episode will be continued, and we will mill that seat. I mean, you have to do it. Some of them are quite wide, some of them are really narrow, but all of these, oh, that one right there was a narrow one, but it was kind of deep. But all of them will be, if you put the ruler down in there, all of them will be the same depth from this flange here to the same depth, and it's also on the same plane. Let's get over there on that milling machine and carry on with this project.